Ever wondered how your computer remembers things even when it's turned off? Yes, it's all about memory, the unsung hero in the world of computing. Memory is that special place where your computer stores and retrieves information. It's like the brain of the computer, holding on to everything it needs to function. Now imagine if you had different types of memory, each with its unique role and capabilities. Some are quick and nimble, ready to change at a moment's notice, while others are steadfast and unwavering, holding on to information like a fortress. These different types of memory work together in harmony, allowing your computer to perform its tasks seamlessly. And amidst this symphony of computer memory, there's one type that stands out for its unique role. It remembers everything, even when everything else forgets. One of these magical memory types is what we call read-only memory. Sounds intriguing, doesn't it? Dive into the world of read-only memory, or as the geeks call it, ROM. ROM is a type of storage medium that permanently stores data on personal computers and other electronic devices. Like a good friend who never forgets, ROM retains its memory even when the device is switched off. This is what we call non-volatile memory. Now let's imagine the ROM as a library. It's a vast collection of books, but instead of novels or encyclopedias, it houses firmware. Firmware is a special type of software that provides low-level control for a device's specific hardware. It's the fundamental code that tells your device, hey, it's time to wake up and get started. When you turn on your computer, the first thing it reads is the BIOS, Basic Input-Output System, stored in the ROM. The BIOS is like the morning alarm for your computer. It initiates the power-on self-test, POST, to check that all the system's hardware components are working correctly. And this is just the beginning of the ROM's role in your device's operation. ROM is not just the early riser that gets your computer going. It also holds the instructions for processes that your device constantly needs to refer to while it's awake. These instructions are like the computer's how-to guide for communicating with its hardware, managing its system, and much more. In essence, ROM is the steadfast librarian of your device, holding on to essential instructions and guiding your computer every time it boots up. It's the dependable constant in the ever-changing world of technology. So, ROM is like the instruction manual for your computer, guiding it every time it wakes up. Let's dissect this ROM to see what's inside. Imagine ROM as a grid, a vast field of columns and rows. This grid is not unlike a chessboard, but instead of black and white squares, it's filled with cells. Each of these cells is like a tiny box, holding a piece of information. In the world of ROM, these pieces of information are binary codes, the zeros and ones that are the language of computers. Now, this grid is not flexible. It's not a spreadsheet where you can just type in a new number. No, the data in ROM is set in stone during the manufacturing process. The information is etched into the silicon of the chip, permanently inscribed. This is done using a process called masking, where specific areas of the silicon chip are exposed to light to alter its properties and store the binary data. Let's take a deeper look. Each cell in the grid contains a fuse or an antifuse. A fuse is like a bridge that can be burnt down, and an antifuse is a gap that can be bridged. The state of the fuse, or antifuse, whether it's intact or burnt, bridged or not, represents the binary data. If the fuse is intact or the antifuse is unbridged, it's a 0. If the fuse is burnt or the antifuse is bridged, it's a 1. And that's how data is stored in ROM, a complex grid of fuses and antifuses, each holding a bit of binary data. But remember, once this data is written, it's there for good. You can't change it. The fuses can't be unburnt, and the antifuses can't be unbridged. You can read this data, access it, use it, but you can't alter it. And that's the beauty of ROM. It's a reliable, permanent store of information that your computer can always depend on, no matter how many times it's powered on or off. It's like a library of essential data that your computer needs to function correctly. That's why it's called read-only memory. You can read it all you want, but no writing allowed. Did you know there are different types of ROMs? Now that may come as a surprise, but it's true. Let's dive into the fascinating world of ROM variations. First off, we have PROM, or Programmable Read-Only Memory. This type is a blank canvas when you first get it. You can program it once using a special device called a PROM programmer. Imagine it's like writing a book, but once it's written, you can't erase or change anything. It's etched in stone, or in this case, silicon. Next, we have EPROM, which stands for Erasable Programmable Read-Only Memory. Now this is where things get exciting. You can program and erase EPROM many times over. How, you ask? Well, you expose the EPROM chip to ultraviolet light. It's like using a magic eraser. The light wipes the chip clean and you can program it anew. But remember, this isn't a task you do at your desk. It requires a special UV light and careful handling. Lastly, we have EPROM, or electrically erasable programmable read-only memory. This type takes the convenience up a notch. Unlike EPROM, you don't need any UV light to erase EPROM. You can erase and reprogram it using electric signals. It's like having a rewritable DVD that you can use over and over again. Plus, you can selectively erase parts of the EPROM without disturbing the rest. Talk about precision. To sum up, PROM is like a one-time storybook. EPROM is a magic book you can rewrite with a UV wand, and EPROM is a high-tech book that you can edit part by part, all with electricity. Each type has its own unique features and applications, ranging from firmware storage to BIOS programming and more. So, not all ROMs are created equal, are they? Each brings its own charm to the table, serving different needs and functions in the world of computing. Isn't it fascinating how diverse and versatile this world of read-only memory is? You might be thinking, why should we care about ROM? Well, the answer lies in the unique characteristics and crucial roles it plays within our computers. Let's dive right into it. Imagine waking up one day and forgetting who you are or what you're supposed to do. That would be pretty disorienting, right? That's exactly what would happen to your computer without ROM. When you power up your system, it's the ROM that wakes up first, nudging the computer into action. This process, known as booting up, relies heavily on the instructions stored in the ROM. Without ROM, your computer wouldn't know how to start, leaving it in a constant state of limbo. But the role of ROM doesn't stop there. It also serves as the custodian of critical instructions that your computer needs to function properly. For instance, the BIOS, or basic input-output system, which is vital for your computer to understand how to interact with its various hardware components, is stored in the ROM. This is because the BIOS needs to be accessible the moment the computer powers up, long before the other components spring into action. ROM's final act of heroism is maintaining data integrity. Unlike RAM, which forgets everything once the power is turned off, ROM retains its data. This non-volatile nature of ROM ensures that important system information remains intact, even in the event of a power outage or system crash. In essence, ROM is the steadfast lighthouse guiding your computer through the foggy waters of booting up, system operations, and data retention. It's the silent hero, working behind the scenes to keep your system running smoothly. So, the next time you switch on your computer and it springs to life, spare a thought for the humble ROM working tirelessly in the background. Without it, your computer would be lost, struggling to find its way. Or in other words, without ROM, your computer would be like a ship without a compass. So, we've journeyed through the realm of read-only memory. We've discovered that ROM is a type of non-volatile storage, retaining information even when the power is off. It's a veritable time capsule, preserving data crucial to your computer's boot process. We've delved into its structure, revealing how it's etched with data during manufacturing, a process as intricate and precise as a master watchmaker at work. We've also explored the diverse types of ROM, from the unchangeable mask ROM to the adaptable flash ROM, each with its unique capabilities and advantages. And we've underscored the vital role ROM plays in our computers, from booting up your operating system to running firmware that controls your devices. It's not an overstatement to say without ROM, your computer wouldn't be able to start its day. Next time you turn on your computer, remember the silent hero, the read-only memory.